Hello everyone, welcome to Geology Concepts, and this is part 2 of the solution series of GATE 2023. In this we'll be doing the geology section. So let's begin. In the first question it says, or 27th question so to say, which of the following mineral pairs shows solid solubility through coupled substitution of elements? The answer here is albite and anorthite, because they form a plagioclase, which is a solid solution and has Na and Ca, and albite and anorthite both have the same structure. So therefore this will be the answer. We know that albite, oligoclase, andesine, and then you have labradorite, bitronite and anorthite. So this is a coupled substitution of elements. All of the others are not having this kind of a coupled solution. They don't have a similar structure. The behavior of the trace gases in magmatic system, it follows Henry's law, where the solubility of a trace mineral is dependent on the volatile that is present around the magma. 29. Choose the correct statement regarding the crystallization of single feldspar of composition this and this. So see this here, the first diagram that you see here, this is of a hypersolvus, and the last one here is subsolvus. Now let's say if you take 50-50 orthoclase and albite, right? So you will get a single feldspar in this range. You will get a single feldspar here in the hypersolvus. But when you move to subsolvus, where the impurity in the form of water increases in the melt itself, then the melting point decreases, and when it comes down it intersects with the solvus. Now if you have a 50-50 bulk, let's say the liquid bulk composition is 50-50, then in that case you will never get a single feldspar that is of this composition, the bulk composition, because at this point it will start to exsolute, and you will get two different feldspar from here on. You will never reach this point. Therefore in subsolvers it is not possible to have a orthoclase 50 and albite 50 single feldspar. You will get that composition, but that will be exsolute, or there will be exsolution before the single feldspar forms. So the mineral can form in hypersolvus but not in subsolvus feldspar system. So A will be the correct option. Given delta V and delta S are the volume and entropy of a reaction, respectively, the most suitable condition for the reaction to be used as geothermometer. Now in a PT diagram, if this is my PT diagram, for a good geothermometer I need a reaction which has a very high slope, because I have to constrain my temperature, right, to a narrow limit so that I can make it a good geothermometer. For that it is very good if you have a almost vertical reaction, the slope of the reaction, but that's not generally possible. But the more the slope, the better the thermometer it is. So the slope of this is dp by dt, right? And from Clausius-Clapeyron equation we know dp by dt is equal to del S by del V. Now for this to be high, for this slope to be more, this delta S should be large and delta V should be small. A smaller delta V will also give you a higher dp by dt, and more delta S will also give you higher dp by dt. So best condition is to have a small delta V and large delta S. So A will be the correct option. In which of the following given mass extinction event, global cooling that resulted in the glaciation and lowering of sea level is considered as a major cause of extinction for more than 50% of marine fauna? A is the KT extinction, Cretaceous Paleogene extinction, which asteroid impact was the reason, so this is not the correct option. Permian Triassic increasing temperature was the reason, so B is also not correct. Ordovician Silurian is a global cooling type of a mass extinction in which the sea level declined, the sea level fall, and therefore most of the marine fauna, they got exposed out of the ocean, and therefore they got extinct. So C is the correct option. Process of fossilization affecting an organism from its death to burial. The important part here is death to burial. This is called as biostratinommy. The whole fossilization process, the study of that is called as taphonomy, but only from death to burial part is biostratinommy, which is a part of taphonomy itself. After burial, what organisms are preserved and how it is how it got preserved, that is your taphonomy. But from dead to burial, it is biostratigraphy. The dip and the dip direction of the lee side of the straight crested cripple on modern sediment is found to be 15 degrees and not 10 west. Consider unidirectional water movement, the flow direction. So when you make a ripple in which this is the toss side and this is the lee side, so this is the flow direction. So whatever is the dip direction of the lee side, that will be the flow direction. Now here it is given that the dip direction is north 10 degree west, so the flow direction will also be the same. So A will be the correct option. Rhodochrosite in hand specimen is most likely to confuse with varieties of. Rhodochrosite is slightly pink colored rock, right? So it can be confused with orthoclase, which is K feldspar. That is also pink in color. So there can be some confusion in the hand specimen. The confusion can be removed by looking it in the thin section, but in hand specimen both are of nearly pinkish color, and that's why there can be confusion. Which of the following is not an essential property of the mineral? Natural occurrence is the essential property of the mineral, so this is not the correct option. Regular internal structure is also an essential property. You cannot have a mineral which does not follow a regular internal structure. Solid state is also a essential property with the exception of mercury. Otherwise, so this is also not the correct option. All the minerals should be solid. Fixed composition is, fixed composition is a property of a mineral, but it's not an essential property of mineral, because in some minerals the composition can vary in a narrow range, and therefore it is not essential property. It's a property that has a fixed composition, it's a compound, but it is not an essential property because some minerals can have composition that vary in a certain range. So C will be the correct option. Number of lattice points in a face-centered cubic. If you look at a face-centered cubic, here all the faces will have a lattice point which will be shared between two of the two unit cells. So 6 faces and share is half, so 3 lattice points here, and at every corner there are 8 lattice points. So 8 into 1 by 8, because each corner is shared between 8 unit cells. So this is 1, so total will be 4. So D is the correct option. All the faces of an octahedron can be collectively symbolized by. See, if you look at an octahedron here, it has this face which is 1 1 1, the bottom face which is 1 1 bar. So this can be represented by a family of planes. Family of planes 1 1 1 can, because it contains all the type of combination. Like it will have 1 1 1 bar, it will have 1 1 bar 1, it will have 1 bar 1 1. All those combinations, total 8 combination, 4 at the top, 4 at the bottom, and therefore D will be the correct option. C option is just one plane, so it is not representing the it's not representing all the planes of octahedron, it is just representing this plane, right? 1 1 1 in square bracket, it's a direction, this is a zone symbol, and this doesn't mean anything, so D is the correct option. Shallow focus earthquake with the tensional focal mechanism are characteristic of subduction is a compressional. Shear zone is also compressional. Transform fault might not be tensional, neither compression. They slide past each other. Mid-oceanic ridge is a tensional mechanism because it is moving away, and you will have all normal faults in this region. Shallow focus earthquake, normal faults, mid-oceanic ridges. 90% of the bulk earth is constitutes of Fe, SiO end. So if you look at the composition of the whole earth, it is the highest is iron, followed by oxygen, then you have silica, and then you have magnesium, which is 13.9% in the bulk earth. So C is the correct option. You must remember the ratio, the order in the crust also and in mantle also. In core it is majorly iron. So here in this case it is talking about the bulk earth, so C will be the correct option. Moving on, which of the following is or are the slope stabilization method? Bolting can be used as a slope stabilization method like this. Application of shotcrete, as you can see here in this figure, the shotcreting is done to make the slope stable. Geogrid can also be used. As you can see here, the grid is applied over the unstable slope so that it doesn't go off. So protection, stabilization method. Impression packer is not used for slope stabilization. It is just used to get the impression of fractures by putting a wax around the borehole. So this is not a slope stabilization method. The answer will be A, B, D in this case. What even the amount of Fe in the sample of 25 gram pyrrhotite FeS is? Now see, to calculate this, first we need to know the number of moles of FeS. So in this case, moles of FeS will be equal to 25 divided by 55.85 plus 32.06. This is the moles. Now the amount of Fe will be molecular mass of Fe 55.85 into moles of Fe, which is 25 divided by, because Fe will be also of the same moles as because it is 1:1, right? 1 mole FeES will have 1 mole Fe. So these many moles will have these many moles of Fe. So 55.85 plus 32.06. This is the ratio. Now if you solve this, you will get the answer. So answer in this case will be, I have already solved it. So answer is 15.88 grams. Okay. The rate of spreading about symmetric spreading center at the middle of a 4000 kilometer wide sea is 40 millimeters per year. Now see, the spreading center is like this, right? The rate of spreading means the rate at which they both are moving apart, A and B. The rate at which they are moving apart is 40 millimeters per year. The moving apart means if you are standing at B, or let's say you are standing at A, then you see B as moving apart from you at the rate of 40 millimeters. So VA minus VB is given as 40. Now because both of these will be equal, I can write this as VA plus VB is equal to 40, which is 2 VA 40, because I am taking VA is equal to PB. They are spreading at the same rate on both the sides. So from here VA I get as 20 millimeters per year. And this whole sea, if we talk about this whole sea, it is saying is 4000 kilometer wide. So one end will be around 2000 kilometers. So your time, if you to calculate, if it will be time is distance upon speed, so 2000 divided by 20. It is in millimeters. You have to convert this also in millimeters. Okay, so 1000 kilometers. If I multiply by 1000, it is meter. If I multiply by 1000 again, this is millimeters. So this is 20 millimeters per year. So I'll get answer in years here. So this is gone, this is gone, this is 2, this is 100. It is 100 into 10 to the power 6. I have to give answer in million years, so it is 100 million years. So spreading began 100 million years before the present. A vertical aerial photograph is obtained over a flat terrain with a 30 centimeter focal length camera lens from a latitude of 18288 meters. If the width of the dolerite dike in the vertical photograph is 2 millimeters, the actual width of the terrain. So to calculate this, first we need to know the scale. Scale is given by F by H. F is the focal length, which is 30 centimeters, and height, what is the height? 30 centimeter focal length camera length, altitude of 18288 meters. So it is 1828800. This is in centimeter, this is also in centimeter. So this becomes 1:360,960. This is the scale, 1:60960. Now you have to calculate what is the width of a dolerite dike. So width of a dolerite dike will be, see, for anything that is 60960 millimeters will be 1 millimeter on the photograph. So what will be the length of 2 millimeters, right? What will be the thickness of, or the scale of something which is 2 millimeter on the actual ground? So this, we have to solve for this. From here we get 0, 2 6 are 12, 1 2 9 18, 119, and 2 6 are 12 again. This, and convert this into meters. Right? This is in millimeter. So if I have to convert this into meter, it will be, I divide by 1000. Right? If I divide it by 1000, I'll convert millimeter into meters. 10 and 100. Yeah. So 1 2 3. So 121. So it will be 121.92 meters. And that will be the answer. I can approximate it to, yeah, 121.92 will be correct. The decay constant of a radioactive isotope is the half-life. This is a very easy question. The formula for half-life directly is 0.693 divided by lambda. So if you solve for this, 0.693 divided by 1.21 into 10 raised to the power minus 4. If you solve this, you will get, I have already solved this. Yeah, so you will get 5727 years. This is the closest integer to this. So 5727 years. The outcrop pattern of flat topography represent, now the fold axes are plunging inward, so it has to be a depression, so it cannot be culmination, not horizontal, or plunging and deformed. There are two hinges here. So D is the correct option. Synform with an synform because it is spreading as you go away. So synform with axial depression. D is the correct option. Match the following taxa. And this, the bryozoa is zooid. Foraminifera is chambers. Ostrocoda is carapace, and conodont is denticle. So A will be the correct option. In the figure schematic diagram, crossbeds are exposed on a vertical rock face. The feature XY in the bold line, which is because you see it is eroding one of the four sets here. So this is a reactivation surface. A. The schematic diagram represents thin section on the carbonate rock. The type of cement that is formed by large calcite crystal is known as. This type of cement is called as poikilotopic cement. Large optically continuous crystal envelope that envelops several grains. The cement here is calcite. So B is the correct option. See, overgrowth is generally around the crystal. Right? Isopachus is like a linear fibrous kind of a thing. Meniscus is between two, let's say there are crystals, and between this crystal the gap is there, that is meniscus. So B is the correct option. Based on the statement, three statements given below, choose the correct option. Statement 1. Echinoids have a water vascular system. This statement is correct. The epithelium and pedicle foramen are found in the brachial wall of the parenchyma. This is wrong because it is found in the pedicle wall. So statement 2 is incorrect. Cardinal teeth, erector muscles, and chondrophore are found in bivalves. This is correct. So A is the correct option. The total number of symmetry elements in the crystal class is represented by the point. This is the normal class or holoidal class of isometric system. Just like all the symmetry that is present in a cube. Right? So if we see a cube, there are 3 A4, there are 6 A2 axes, there are 4 A3 axes, there are 9 mirror planes, and there is 1 center of symmetry. These are the total symmetry element that are present. If I add it, This is 10, this is 10, and this is 3, so it is 23. 10 plus 10 plus 3. So C is the correct option here. 23 symmetry elements. The ratio of bridging to non-bridging oxygen atom in the amphibole structure. So if we look at an amphibole structure, it is like this. Double chain silicate, which goes on like this. So the repeating unit in an amphibole is this part. I can say this part is the repeating unit. This whole thing. So if we consider this only, if you see, this is a bridging oxygen, this is a bridging oxygen, and this is a bridging oxygen, and this is a bridging oxygen. So this is half inside this is half, this is half, so this is 1.5 and this, so 2.5 is the number of bridging oxygens. And if you look at the non-bridging oxygen, so this is non-bridging, and this is non-bridging, and this is non-bridging. So 1, 2, 3. So non-bridging is 3. Now you have to take the ratio of this. Bridging to non-bridging is 2.5 divided by 3. So if you solve it, it is 5, 5 is 25, 6, 5 is to 6. So B will be the correct option. Okay, match the following basins. Okay, so for Kaveri it is Kalamedu, Damodar it is Raniganj, so P4, Q3, Chhattisgarh it is Lohadi, and Indravati it is Tiratgarh. So A will be the correct option. Okay, based on the statement given below, choose the correct option. Gigantopithecus is a genus of family Homidae. This is correct. It is great ape. Equus is the living genus of the family Equidae. This is also correct. And Gomphotherium is a genus belonging to the order Proboscidea. It belongs to the elephant family, order Proboscidea. This is also correct. So all the three statements are correct here. In porphyric copper deposits, the order of alteration zones from the intrusive bodies outwards is. So if you look at this structure, if you go from inside to outside, you have potassic followed by philic, then you have this argillic, and then finally it is propylitic. So C is the correct option. Potassic, philic, argillic, and propylitic. Which is the correct sequence of ore minerals in the increasing order of the reflectance? So the correct sequence here is C, is ferrite, magnetite, galena, and pyrite. Which of the following stratigraphic succession is or are correct? Moot quartzite, Syringotherese limestone, Fenestella shale, Panjal, this is correct. Badakar, Bijri, Panchmadi, and Bagra. This in Damodar Valley, you can see this, I guess. This is also correct. Chitravati, Papagani, Nallamalai, this is wrong. Papagani is before that, so this is wrong. Kamur, Semri, Bandergo, and this is also wrong. So A and B is the correct option. Which of the following mineral represent the simultaneous crystallization of two minerals? Granophyric. Granophyric is correct. See, what happens is there is H2O dissolved in the H2O which is present in the magma. So the boiling point lowers down, right? So it comes here. Let's say this is quartz and this is feldspar. So feldspar and quartz boiling point are because of the impurity H2O. The boiling point goes below, right? It comes somewhere here, and when there is a removal of H2O due to when H2O escapes out of this liquid, when it is shallow near the surface, and in that case the melting point again it increases to this value, and your actual temperature is somewhere here. So they both crystallize rapidly and there is intergrowth. So that's why you have granophyric texture in which there is simultaneous crystallization. Myrmekitic, it is also a simultaneous crystallization of plagioclase and quartz. because it is forming from orthoclase. If you look at the plagioclase orthoclase boundaries, this is plage and this is orthoclase. When plagioclase intrudes here, orthoclase converts into plagioclase plus SiO2. So they both, form together. So B is also correct. Corona of orthobicentennial, this is wrong. Cumulate pyroxene, this is also wrong because pyroxene will not form simultaneously. So A and B is correct. May the following texture suggest post-kinematic growth of the mentioned mineral. Okay, randomly oriented chloride grain. This is correct because post-kinematic means the grain which you are talking about has formed after the deformation or the kinematic process. So if it is forming after the deformation, then there is no stress that will keep it aligned, or there will be no preferred orientation. It will be randomly, growing in all the directions. So A is correct. It is post kinematic. Garnet porphyrobrite wrapped by wrapped. If it is wrapped, that means it was already present there. So it is not post kinematic. If there is any kind of wrapping of a porphyroblast, that means it is either syn kinematic or pre kinematic, but it is not post kinematic. So B is wrong. Foliation during biotite wrapping around a porphyroblast. So again, this is also pre kinematic. So this is wrong. This is generally syn kinematic. This is pre kinematic. Porphyroblastic garnet containing helicitic fold as internal cystosity. This is correct. See, when your mineral has a similar type of cystosity inside it also as it is outside, this means that the grain has formed after this foliation has happened. So therefore it is post kinematic. A and D will be correct. In the cross section of a hill, the planar discontinuity intersects with the planar slope phase. Using kinetical analysis, which of the following favors the failure? See, if the discontinuity has less angle than the slope phase, see, slope phase has a dip of this, and if discontinuity has less dip than the slope phase, then it is easy to get failure. So the dip of the discontinuity surface is less than the slope phase. If this is the case, then it is favorable for failure. Friction angle on the discontinuity surface is more than the dip of the slope phase. See, what is friction angle? So if this is a wedge, right, and there is a object kept here, right, it has a mass, let's say mg. So this will be mg sine theta, and this will be mg cos theta, and this will be the friction, right? So a friction and the normal that is acting will be mg cos theta because it is not moving in this direction. So friction is defined as mu times n, right? It is defined as mu mg cos theta. This should be equal when it equals to this force, which is mg sine theta. From here we get mu is equal to tan theta. This theta is the friction angle, which is this angle. So if this angle is more than the value which friction can sustain, this block will start sliding, right? If theta is more than the mu equal to tan theta, right? So this is the friction angle. Now if I increase the angle, it will definitely start moving. So this will favor the movement or failure. So if the friction angle of discontinuity it is more, if friction angle is more, then it is stable. If the friction angle is less than the dip of the discontinuity, that means this force is more, and therefore it will favor. So C is correct. The dip direction of the discontinuity surface is same as that of the slope phase. Yes, if the discontinuity is in the same direction as this, if it is dipping in the same direction or dip direction is same, then it will favor, right? So D is also correct. Good. So A, C, D is the correct option, are the correct options. In a drainage basin, the number of the first, second, third and fourth and fifth streams are this. So we know what is bifurcation ratio. So RB1 is 240 by 40, which is 6. Bifurcation ratio for second order, it is 40 upon 8, which is 5. Bifurcation ratio for third is 8 by 2, which is 4, and bifurcation ratio for the fourth order stream is 2 by 1, which is 2. Now the average bifurcation ratio will be 6 plus 5 plus 4 plus 2 divided by 4. Now this is 17 by 4, which is 16.25. 4.25 will be the average bifurcation ratio of this whole basin. Okay. A sandstone follows Mohr-Coulomb failure criteria. Now, if the uniaxial compressive strength of the angle and the angle of the internal friction of sandstone is this, so Mohr-Coulomb fracture criteria is given by tau is equal to tan theta sigma plus c. Okay, which is the equation of this line. This is the Mohr-Coulomb fracture criteria. Now this is the theta angle, which is given in the question as 30 degrees. Now this point lies on the circle also and on Mohr-Coulomb also. So this point will satisfy this equation, right? So if somehow we know the value of tan theta, if somehow we know what is tau and what is sigma at this point, we can calculate the cohesion. Now this uniaxial compressive, so this is 7 megapascal and this is 0. That means the radius of the circle is 3.5. If this is whole thing is 7, this radius value will be 3.5. Correct? Now if we try to solve for this point, see, this is a tangent and this is the radius, so this angle will be 90 degrees. This is 30, so this will be 60. Now if this is 60, this is 60, so this will be 30 and this will be 60, right? So this length and this length we are interested in, right? So if I calculate 3.5 cos 60, okay, 3.5 cos 60 degree, I'll get this length. So and if I calculate 3.5 cos 30, I'll get this length. So this will be my tau. 3.5 cos 30 will be tau. I think this makes sense. Now I need this point, right? This whole thing is 3.5. If I subtract this length from 3.5, I'll get this point. I'll get this length actually. This is what I'm interested in, right? So the correct option here will be, the correct solution will be 3.5 cos 30 is equal to, the sigma value here is 3.5 minus 3.5 cos 60 into tan theta. Now tan theta is 1 upon root 3 plus c. Now you have to solve for this, right? If you solve for this, see, 3.5 cos 30 is root 3 by 2. Cos 30 sin 30 is half, so cos 30 will be root 3 by 2 is equal to 3.5 1 minus cos 60 is half, 1 minus half into 1 by root 3 plus c. Now 3.5 to keep solving, so this is 3.5 root 3, 3.5 by 2, I can call this as root 3 minus, this is 3.5, 1 minus half is again half into 1 by root 3. This will be c. So if you take 3.5 by 2 as common, 3.5 by 2 common, inside you will get root 3 minus 1 by root 3 is equal to c. So from here we get C is equal to 3.5 by 2, inside root 3 this is 2 by root 3. So 2 gets cancelled, 3.5 by root 3 will be the answer. So 3.5 by root 3 is 3.5 divided by 1.732, and this will come out to be 2.0207. Now it is saying it to round off to 2 decimal, so this will be 2.02 megapascal will be the cohesion, which is this length. This length will be 2.02 megapascals. It's a good question. At a certain depth in the crust, the maximum and the minimum compressive stresses are 150 and 75 megapascals, which led to the normal faulting. Now, in the average density of the crust is this, the crustal depth. See, according to, if this is the surface and you are getting a normal fault, let's say at the depth of h, okay, then your sigma 1 will be in this direction, then only you will get this, and sigma 3 in this direction. So now it is saying 150 and 75 are the maximum and minimum, so 150 is sigma 1. So at this point the pressure is 150 megapascal. So now I can equate this to 150 equal to rho g h, and I can calculate what is the value of h. So 150 is equal to rho is 2700 into g is asking to take 10, and you have to calculate h. So from here you will get answer in it is megapascal, so 10 to the power 6 Pascal. Now everything is in SI unit. We can calculate the value of h. We have to calculate it in kilometers. So it will be 10 to the power 3. I have converted in kilometers, so it will be 10 to the power 3 into 15 upon 270. If you solve this, you will get around 5.6 kilometers, I guess. 5.5 to 5.6 kilometers. Okay. Question number 63. In a cylindrical soil sample of 10 centimeter diameter is tested on a constant head permeameter. A volume of 250 centimeter cube of water is collected in 5 minutes when the constant head difference between the tapping point is 15 centimeter apart is 5 centimeter. So the head is 5 centimeter, so hydraulic gradient will be, so it is asking what is coefficient of permeability. Okay, so Darcy velocity is equal to Ki. I is hydraulic gradient, so this is 5 by 15. K we have to calculate, and V is the, V can be written as Q by A, and A, if I bring it this side, Q is the volume flow per second, right? So Q is 250 cc divided by 5 into 60, which is 300 seconds. This is equal to pi r square. R here is 5 cm, diameter is 10, so it is 5 into 5 into K into 5 by 15. So 5 3s are 15, 3 is 100, 5 this is 25, so 10, this is 1 by 10, so K comes out to be 1 by 10 upon pi, which is 0.1 upon pi. The value of 0.1 upon pi, if you calculate, it will be 0.031. This is the value of K in centimeters per second, so 0.031. Next question. Question number 64. The minimum anion to cation radius ratio at which a threefold coordination becomes possible. So this is the figure for the threefold coordination, and there is this 3 anions A, B and C, and center this is a cation. Now if you approximate to this triangular figure of this length, will be radius of anion plus cation, which is r plus r, which is this length, right? Considering this angle to be 30 degrees, right? And this will be the radius of anion. So this is r. So from here we can say that r plus r cos 30 will be equal to r according to this triangle, triangle BOD. It's a right triangle. So r plus r is equal to this. So from here we can calculate. Achha, what the question is asking is minimum anion to cation. Anion to cation means is asking what is r by r. Okay. So now if we calculate that, from here we get r plus r by r is equal to 2 by root 3. Now if I subtract 1 from both the sides, r plus r, or distribute it, distribution will be easy. If I distribute it, I'll get 1 plus r by r is equal to 2 by root 3. So from here we get r by r is equal to 2 by root 3 minus 1. So this is again equal to 2 minus root 3 divided by root 3. So what question is asking is r by r, not small r by capital R. So anion by cation. So this comes out to be root 3 divided by 2 minus root 3. Now if you solve this, this is 1.732 divided by 2 minus 1.732. So here you will get 6.45. So this is equal to 6.45. Okay. Coming to question number 65th, the mole fraction of jadeite in pyroxene. So mole fraction of jadeite is defined as moles of jadeite and divided by total number of moles, right? So if we take 1 mole of this whole thing, this whole Ca 0.67 Na, this and this whole thing, let's say it is 1 mole. So whatever is the moles of jadeite in it, that will be the mole fraction, because denominator becomes 1. So we have to just calculate the moles of jadeite. Now if the whole jadeite formula is NaAl Si2O6. So, and there is no aluminium in pyroxene, right? Pyroxene formula will be cation twice Si2O6. So there is no aluminium here. If there is aluminium, it will be in tetrahedral coordination, but this is Si2O6, that means there is no tetrahedral aluminium. All tetrahedral is sites are occupied by silica itself. So this whole aluminium 2.208 is present in the jadeite. So if 1 mole of jadeite will have 1 mole of aluminium, so how many moles will have 0.208 of aluminium? It will be same, 0.208 moles of jadeite will give you 0.208 moles of aluminium. So I think the mole fraction will be 0.208 divided by 1. So this should itself be the answer. So it is 0.208. I am not considering Na in jadeite because some Na can also be present in the pyroxenes in some times. So that is why. So this is how you go about it. So that's it. This is the solution for GATE 2023 geology paper, and have a good day. See you in the next video.